Why the shift to autonomous multi-turn artificial intelligence requires a fundamental breakthrough in hardware architecture. The shift to autonomous multi-turn artificial intelligence is happening now. This transition requires a fundamental breakthrough in hardware architecture. Standard hardware is no longer sufficient. We need a new foundation for these complex artificial intelligence agents. Transition to multi-turn agentic workflows. When building complex artificial intelligence agents, the processing requirements do not scale linearly. They compound. An agent does not just output a single response. It runs in a continuous loop. This loop includes reasoning steps and writing code. The agent then reviews its own work. Finally, it calls external application programming interfaces. The exponential latency penalty of standard hardware. On standard hardware, a complex multi-step task makes the system feel very clunky. We are analyzing an Nvidia H100 graphics processing unit cluster. This system achieves a throughput of approximately 70 tokens per second. A single 5-turn agent loop forces the user to wait for over 1 minute. The latency compounds exponentially with every single turn. Breaking the bottleneck. 750 tokens per second. We can break this latency bottleneck with the Cerebras Wafer Scale Engine 3. Let us compare it with a standard H100 cluster. A single turn of 1,000 tokens takes 14 seconds on standard hardware, but the Wafer Scale Engine 3 completes this in just 1.3 seconds. For a deep reasoning step of 3,000 tokens, the H100 takes 43 seconds, while the Wafer Scale Engine 3 takes only 4 seconds. A full 5-turn agent loop takes over 1 minute on standard hardware. The Wafer Scale Engine 3 completes the entire loop in 6.5 seconds. This entire multi-turn thought process happens in the time it takes to blink your eyes a few times. It's a physics problem, not a software optimization. This bottleneck is actually a physics problem rather than a software optimization issue. Standard architectures are fundamentally limited by communication walls between chips. Massive amounts of time and energy are wasted moving data back and forth between individual chips and external memory. The Wafer Scale Engine 3 solves this problem. It uses a single giant slice of silicon measuring 46,000 square millimeters. This keeps the entire process on a massive unified substrate. The Wafer Scale Engine 3 streaming weights without barriers. The Wafer Scale Engine 3 is a single slice of silicon measuring 46,000 square millimeters. This architecture eliminates typical communication bottlenecks between chips by offering a memory bandwidth of 21 petabytes per second. Model weight stream layer by layer from external petabyte scale storage at an unprecedented speed. Hardware paradigm shift. This comparison summarizes the massive hardware shift from fragmented graphics processing unit clusters to the single-slice Wafer Scale Engine 3. Fragmented clusters suffer from high friction data movement and constrained memory bandwidth. The Wafer Scale Engine 3 eliminates inter-chip communication entirely on a unified substrate. It offers 21 petabytes per second of continuous streaming. Throughput increases from 70 tokens per second to 750 tokens per second. This transitions the multi-turn user experience from a clunky 1.1 minute wait to a real-time loop of 6.5 seconds. The new baseline for production-grade agents. This is the new baseline for production-grade agents. We combine Sol's high-tier reasoning with 21 petabytes per second of raw throughput. This combination creates real-time agents for production environments. The launch of this technology is now cleared by Washington. Pairing raw throughput with advanced reasoning models will fundamentally alter what agents can accomplish in real time.